All right, we hear the term AI learning thrown around all the time. But what's actually going on under the hood? It can really feel like some kind of magic. But today, we're going to pull back the curtain. We are going to break down, step by step, the real mechanics of how a machine goes from knowing absolutely nothing to mastering some incredibly complex skills. Okay, so to really get how AI learns, you kind of have to throw out your old ideas about how software works. For decades, programming has followed a very specific logic. But machine learning? It's not just an update, it's a complete flip of the script. And here is that flip in action. See, in the old world, a programmer, a person, would sit down and write a bunch of rigid rules. You'd feed the program data, it would follow those rules exactly, and boom, out pops an answer. Machine learning does the exact opposite. We give the machine a ton of data, but we also give it the right answers. The machine's entire job is to look at all of that and figure out for itself, okay, what are the rules here? Now, this shift has some huge consequences. We're moving away from a world of stiff, if this, then that logic, to one that's all about flexible, probabilistic patterns. I mean, think about it. Traditional programs are brittle. If something changes in the real world, a human has to go in and manually rewrite the code. But machine learning models, they can adapt all on their own as they see new data. And that is exactly what makes them so good at handling the messy, ambiguous stuff, like telling a cat from a dog, where writing down all the rules would be, well, basically impossible. So if the machine's job is to learn the rules, what is the machine doing the learning? Well, it's a structure that's actually inspired by our own brains, and it's called an artificial neural network. So this huge, complex network is actually built from millions of these teeny, tiny, simple components called artificial neurons. And you can think of each one as its own little decision maker. Just like a neuron in your brain, it takes in signals from other neurons, it decides how important each signal is, and then it makes a call on whether to fire off a signal of its own. It's the absolute fundamental building block. And every single one of these neurons has a simple three-step job. First, it weighs its inputs. Think of these weights like little knobs that you can turn up or down to signal how important each piece of information is. Then it adds all those weighted inputs up, along with something called a bias, which is kind of like a thumb on the scale, making the neuron just a little more or less likely to fire. And finally, all that gets passed through an activation function. You can think of that like a dimmer switch that decides how strong the output signal should be. Now, one of these neurons on its own isn't very smart, but when you get millions of them working together, that's where the magic happens. Okay, so we've got the building blocks. Now let's see how a brand new, totally untrained network uses these neurons to make its very first, completely uneducated guess. This whole process is called the forward pass. And this is so important to remember. At the very beginning, the network is a total blank slate. It knows absolutely nothing. All those little internal knobs, the weights, are just set to random values. So its first prediction? It is quite literally a wild guess. So what happens during this forward pass is that data flows in just one direction. It starts at the input layer, let's say all the pixels in a picture. Then it ripples through all these hidden thinking layers in the middle. And finally, it arrives at the output layer, which spits out the network's prediction. The information just moves straight on through. Okay, so a random guess is almost always going to be wrong, right? But here's where things get really interesting. That mistake isn't a failure. It's actually an opportunity. The whole system is designed to learn from its errors. And the very first step in learning is putting a number on just how wrong that guess was. This is done with something called a loss function. It takes the network's guess, it compares it to the actual right answer, and it calculates a single number that represents the size of the mistake. A big number means you are way off, a small number means you are getting close. As the great James Brown once said, you have to pay the costs to be the boss. And for an AI, that cost is its error. By calculating the exact price of its mistake, the network gets the one piece of information it absolutely needs to start getting better. So this is the heart of it all, this learning loop. After you calculate the error, the network kicks off a process called backpropagation. And just like it sounds, it works backward from the final error, using a bit of calculus to figure out exactly how much blame each one of those millions of little knobs, or weights, deserves for the mistake. Then a process called gradient descent comes in and makes a tiny, tiny adjustment to every single one of those knobs, nudging them in just the right direction so that the next guess will be a little bit better. And that's basically it. Seriously, that simple feedback loop, guess, check your error, and adjust all the knobs, that is the fundamental engine that powers pretty much all of modern AI. It's not magic, it's just math and doing it over and over and over again. And this is where the mind-boggling scale comes in. This loop doesn't just run a few times. It's repeated millions or in some cases even billions of times on enormous sets of data. And with every single cycle, every single pass, the network's internal knobs get tuned just a little bit more precisely, and its guesses get a little more accurate. So what starts out as a series of completely random guesses slowly, incrementally turns into the sophisticated intelligence that we use every single day. The ability to automatically tag your friends in photos, to filter junk out of your inbox, or to talk to a virtual assistant. It all comes back to this one fundamental process of trial, error, and tiny corrections just done at a massive scale. So if you take one thing away from this, it's this. AI doesn't learn through some mysterious, magical consciousness. It learns through a surprisingly simple mechanical process of guessing, measuring how bad its guess was, and then adjusting itself to do a little better the next time. It's an incredibly powerful engine for turning mistakes into intelligence, which, of course, leaves us with a pretty fascinating question. Now that we have this engine, what's the next big, complex problem we should point it at?